The next problem we are doing is from Chapter 3, Section 3, page 152, problem number 21. We are given the problem f of x equals x plus 2 quantity squared minus 2. Now this problem is in vertex form and we are told to graph. The first thing we do is we're going to identify our vertex. Alright, the vertex is always h, comma, k. H, this is in the form of y equals a times x minus h quantity squared plus k. So that means negative h equals positive 2, then positive h has to be negative 2. K is negative 2 because there's no sign change in the formula here. Now we know our vertex. So first thing we'll do is we're going to draw our xy axes, y-axis, x-axis, Alright, we put a few marks on there. Now, our point, negative 2, 2. So we go left to negative 2, down to negative 2, put a dot. That is our vertex. Now, because A is positive 1, our graph will open up. Okay, we can make a table if we want. Now, if I choose numbers for x, if I choose negative 1, for example, negative 1 plus 2 is 1. 1 squared is 1. 1 minus 2 is negative 1. So I have the point negative 1, negative 1. Now, since it's symmetrical, that's going to give us the point negative 3. It will also have negative 1 because parabolas are symmetric. So the second point is always a give me. Now, what if I put in 0 into my table? 0 plus 2 is 2. 2 squared is 4. 4 minus 2 is 2. So we have the point 0, 2. And then we also have the give me of negative 4, 2 because of the symmetry of parabolas. So negative 4 up to 2. And we just come, oops. And there is our parabola. Now, we also, in addition to graphing, we have to find the domain and the range of this function. So for part B, the domain, well, domain is where x is defined. I can put any number in for x, positive numbers, negative numbers. I can even put 0 in. So my domain is all real numbers. That means it goes from negative infinity to positive infinity. or I could write out the words all real numbers. Now, for the range, well, you notice both ends point up, so it's going to head toward positive infinity from both sides. But you notice right here at your vertex, it never gets below this point. It never gets below -2, -2. So, for the range, if you like set builder notation, we have a function where y is such that y is going to be greater than or equal to the y coordinate -2. Now, if I want to write in interval notation, I would say this goes inclusive from -2 to positive infinity. Because all y values are greater than or equal to -2. Now, part C says determine where the function is increasing or decreasing. Well, when we go from left to right, all right, if we were following our parabola, it is decreasing from negative infinity, so decreasing from negative infinity until we get to -2. Then it stops decreasing. So we do not use a bracket because that is a point of direction change. It stops decreasing, and as we go from left to right, it starts increasing until you get to positive infinity. So it is increasing on the interval of -2, positive infinity. And there we have problem number 21.